Welcome to Unit 7, Lessons 8 and 9. These are our final lessons in our unit on fractions, and today we'll be discussing problem solving with fractions. Our lesson objective is to use fraction concepts to solve real-world problems. Before we can solve real-world problems, we have to check our understanding of fractions. Let's review by asking ourselves these 8 questions. Number 1, what does a fraction tell you? Number 2, what are the equal parts of a fraction called? Number 3, how do you know that a fraction is a unit fraction? Number 4, how are other fractions made from unit fractions? Number 5, how can you compare fractions with the same denominator? Number 6, how can you compare fractions with the same numerator? Number 7, why can you use different fractions to name half? And finally, number 8, what do you call different fractions that name the same part of a whole? We're going to answer each of these questions, but if you would like to pause the video and answer these 8 questions on your study guide, then when we go through, you'll check your answers to make sure that you understand. Number 1, what does a fraction tell you? Well, a fraction tells us a denominator tells us how many equal parts in one whole, and the numerator tells us how many of those parts are in the fraction. For example, 2/3. The numerator means that we have 2 parts in our fraction of the third, which is the denominator. So we have 2 parts of 3 in our fraction. Number 2, what are the equal parts of a fraction called? Well, we have an apple here that's divided into 4 parts. This is 1/4, this is 1/4, this is 1/4, and this is 1/4. I hope that reminds you of what a unit fraction is. A unit fraction is simply the small one part of the whole. So this demonstrates 4/4 or 1/4, 1/4, 1/4, and 1/4. 1/6 is also a unit fraction, and 1/10 is also a unit fraction. Number 3, how do you know that a fraction is a unit fraction? I hope that when you were thinking about question number 2, this was clear to you. The way that we can tell if a fraction is a unit fraction is simply that the numerator is always going to be 1. So in this case, there is 1/6. If we looked at our lovely pizza here, it is divided into 8 parts, and each unit fraction would be 1/8. Number 4, how are other fractions made from unit fractions? Let's take a look at the answer to this. You just keep putting unit fractions together until you have the fraction you want. For example, if we had 3 pieces of pizza, if we put 1/8 plus 1/8 plus 1/8 equals 3/8 of the pizza, or 3/8 in our fraction. Number 5. How can you compare fractions with the same denominator? The one with the greatest numerator is going to be the greater fraction. Let's look at our example here. We have two fractions with the same denominator, 9. So there are 9 equal parts. If we have 8 of those 9, it is going to be greater than if we have 3 parts of those 9. Number 6, how can you compare fractions with the same numerator? The one with the greatest denominator is going to be the lesser fraction. 2/5 and 2/7. The denominator is different, but the numerator is the same. If you recall, the more parts you divide a whole into, the smaller each unit fraction will be. So 2/7 is going to be smaller than 2/5. Number 7. Why can you use different fractions to name half? You can make 1/2 with 2/4 or 3/6, 6 or 4/8, or in other ways too, as long as each way shows 1/2 of a whole. If you look at our equivalence chain, each fraction identifies half of, so the numerator identifies half of the denominator. 1 of 2, 2 of 4, 3 of 6, 4 of 8, we could go on and on, 10 of 20. This equivalence chain also identifies to us the pattern. Half is always going to be identified in this way. We could go on and on with a unit fraction and in this equivalence fraction in the same way. Number 8. What do you call different fractions that name the same parts of a whole? Same part of the whole. Well, you call them equivalent fractions. That means that they are equivalent in proportion. So 1/3 is equivalent to 2/6, is equivalent to 3/9, is equivalent or equal to 4/12. Now that answers all of our 8 questions. Now let's use what we know of fractions to solve some real-world problems. For example, Bryson has a box of red pencils. He gives 3/8 of the pencils to Olive and 3/6 of the pencils to Michael. To which friend did he give more pencils? Now, remember this question here. What do we know about comparison of fractions that have the same numerator but different denominators? Remember, the box equals the whole. So what we recall is if the numerator is the same, whichever fraction is divided into less parts is going to be a larger piece. The correct answer is more pencils to Michael. Michael will have a larger portion of the red pencils than Olive. Now let's look at applying with a word problem. So we will solve this problem by drawing a diagram or a number line if you need to. Well, I've drawn a number line here for us to practice with. It says, Lester walks 3/4 miles to school. Bert said that he walks farther because he walks 6/8 mile to school. Is his statement correct? Explain your answer. We have 3/4 and 6/8. I've drawn two number lines and divided them in equal parts. Here is the 4th and here is the 8th. Do you notice the answer? I would say you could look at it very clearly and see that 3/4 is exactly the same as 6/8. Let's see if our answer is correct. No, Bert doesn't walk farther. He walks the same distance as Lester. 3/4 is equal to 6/8. Now let's look at another problem. And I have solved this problem with fraction bars. It says either draw a diagram or a number line. In this case, fraction bars is what we've used. Dina's water bottle can hold a total of 2.5 2/5 liters of water. John's water bottle can hold a total of 5 half liters of water. Whose water bottle holds more water? And how do you know? Well, I've drawn a diagram here, and you can see here is 5 halves, and here are 2/5. 5 halves is certainly more water than 2/5. Let's see if our answer is correct. John's water bottle, 2/5 is a fraction less than 1, and 5 halves is a fraction greater than 1, so 5 halves is greater than 2/5. Now let's look at the statement and let's identify. It is very important that we understand fractions and comparing fractions and equivalent fractions. To solve problems, we have to understand how to use them. Is this statement true? So listen carefully. When comparing two fractions with the same numerator and different denominators, the fraction with the smaller denominator is greater than the fraction with the larger denominator. Do you believe that to be true? Let's look at the answer here. It says true. The fraction with the smaller denominator means that the whole has been divided into fewer parts and the parts cover a larger area. For example, 2/3 is going to be greater than 2/4. Okay, ladies and gentlemen, we will be able to take these facts about fractions to a level where we can understand enough that we can solve problems. We will be able to solve some real-world problems using fractions if we understand them. We'll review, but please make sure that you understand these 8 concepts before we meet again to discuss problem solving with fractions. So the assessment for this video, our final video, is to review the questions discussed earlier in the video to assure understanding of fractions, and number 2, to apply problem-solving strategies on real-world problems. Good luck, ladies and gentlemen. I hope that you understand and feel comfortable with fractions at the conclusion of this unit. Have a good evening.